Okay, so the second question is just a little bit below previous question, and it's question number 89. So this looks to be a cool table, and let's try and work out the first A. So you have a table over here, and this table tells you the difference. Oh, where is it? I'm messing. Okay, so this is the um, type of car, whether it's an SUV, sports car, or a compact car, and the color of car. And 377 vehicles were parked. Let's try and answer each and one of these. So what is the probability of finding a white car? The probability of finding a white car is 60 divided by 377. What is the probability of finding a red or a black car? Okay, so now we are trying to think about probability of red or black. Okay, if it really helps, you could always create a table and then label them in much simpler terms. Okay, so here are the okay, so you could call these types of cars as like SUV, sports, and compact. A1, A2, and A3. And you could name just like R. B1 is like black. B2 is blue. And G is gray, and W is white, right? So now it's a probability of red or blue. So it's R or B2. And this means, so what's the probability of red or a black car? This will be the probability of a red car plus the probability of a black car. Subtract out the intersection between them. Okay, so here, what do you try and think? But you try and think about them. So this is the formula. This is your probability of R or B2. This is your addition rule. Okay, but when you actually try and think about these two, a car cannot be red and is it blue or black? Red or black? B1. Okay. So the probability of red or black, these are independent events because a car is not red or and black at the same time. So what's the probability of red? Probability of red is 47 divided by 377. Probability of black is 105 divided by 377. And the intersection between them is 0. Okay. And the third question is, what's the probability that the car is not an SUV? The probability that a car is an SUV, probability of A1 is 133 divided by 377. So the probability of not an SUV, its probability of not A1, which is the complement of it, is 1 minus 133 by 3. Sorry. That's your solution for C. Solution for D, what's the probability that the car is compact and is blue? The probability that the car is compact is A3, and blue. Blue is B2. So this is what we're being asked for. So whenever it's and, you think about the multiplication rule. So this is going to be the probability that the car is compact multiplied by the probability that the car is blue and after conditioning on the fact that it's a okay. So what's the probability that the car is compact? So this is what I wrote. Probability A3 stands for compact and B2 stands for blue. So what's the probability that the car is compact? This is 123 divided by 377 multiplied by what's the probability that the car is blue, and given that it's compact. So this is going to be blue and it's compact. It's 23. Okay. And this is 23. The 23 observations among 123 compact cars. Okay, so that's how you look at it. There are 123 compact cars, and this is 23 divided by 120. This becomes 23 divided by 377. Okay, so that's the fraction and the answer for part D. What's part E? Part E is what's the probability that the car is red or black and is a sports car? Okay, so now we're defining the events a little bit differently. The probability the car is red or black, you know, and probability the car is red or black, B1, and the car is a sports car. The sports car is A2 and A2. So this is what the question is asking for. So it's starting to get a little tricky here. So what's the probability that the car is red or black? We compute that before? Yeah, so we did compute that before. That's the answer to part B, which is 47 plus 105 divided by 377. And that is 147 plus 552 divided by 377. And that is 0.40 or 0.4032. Okay, so that's your actual value. And so that's your probability of R or B1. Okay, and the probability to the firm, so you do have that. So now when you try and think about this is going to be the probability of multiplication rule. The probability, I think it'll be easier to try and think about in terms of A2. This is going to be the probability of the car is a sports car, and multiplied by the fact that the probability of R1, given that it's a sports car. Okay, so what's the probability of A2? The probability of being a sports car is 121 divided by 377. Now if you multiply this by the probability of the car being, given that A2 has happened, okay, so given that A2 has happened, A2 is 121. So your denominator is, you're looking only within the sports car category. What is the probability that it's R or B1? R or B1 is just going to be red, 15, and black is B1, which is 55. It's going to be 15 plus 50. Okay, and this is just going to be 60 divided by 377. Okay, so that's the probability that the car is a sports car and either red or black. Okay, and F is something similar. Car is black, or is a sports car. I'll let you work that out for yourself. Okay, so these are two examples, and I hope this helps.